Right, here we go. We're going to have a look at rates of change, and I'm going to do it for an example. We've got an open cone of height 10 centimeters and a base radius of 5 centimeters being filled with water at a rate of 1.5 centimeters cubed per second. And when the height of the water is 5 centimeters, what is the rate at which the water level is rising? So what we got here is we've been given the rate at which the volume is increasing. Because we've got centimeters cubed volume and per second means over time. So therefore, that is going to be dV by dt. That's what that is, 1.5 centimeters. The rate of change of volume with respect to time is 1.5 centimeters per second. And we want to find the rate at which the water is rising. So that's dH by dt. Yep. Then how much the height is increasing over time. And that's what we need to find. Now, we can relate these two variables, these two rates of change, using volume and height. Okay, because we can find the volume of the cone, and the volume of the cone is equal to 1/3 pi r squared h. Because we've got volume in terms of r and h, and we only want to connect v and h, and we don't want the r. Right, so we can see a relation between r and h. Okay, because the open cone has a height of 10 and a radius of 5, then r and h must be in the same ratio of 5 to 10. So we can see that r divided by h must equal our r part divided by h part, so that's our 5 divided by 10 must be in that ratio, 5 over 10 over 10. So therefore, r will equal a half h. And now we can replace that r with a half h. So let's do that. We've got equation 1, we've got equation 2. If we put 2 into 1, we are going to replace this r here with a half h equal to r. So we're going to get the volume is equal to 1/3 of h over 2 squared, got the pi, there we go, squared times by another h. So the volume is going to be equal to pi over 3 times h cubed over 4, 2 squared. Now we can find dV by dH. And we do that by multiplying by 3. So we're going to get pi h squared over 4, because the 3's cancel. And that gives us dV by dH. Now we've got dV by dt, dH by dt, and dV by dH. So we can use the chain rule to find ourselves dH by dt. dH by dt will equal dH by dV times dV by dt. Okay, using the chain rule, right? dH by dt is equal to dH by dV times dV by dt. Well, let's replace the dH by dV. dH by dV is going to be equal to 4 over pi h squared times dV by dt, which is 1.5 centimeters per second. That gives us our dH. Now, we want to know what that is when the height is 5 centimeters. So when h equals 5, dH by dt will equal 4 over pi times 25 times 1.5. And that comes out to be roughly equal to 0.0764 centimeters per second to 3SF. To 3SF. So remembering this, we get given some information in the question. The easiest way to see what this represents is by looking at units, centimeters cubed, volume per time, so dV by dt. We want the rate at which the water's level is rising, dH by dt. Now, we can look for connections in here in the problem. Well, we know we can relate volume to height, because we can get volume equals 1/3 pi r squared h. Now, the tricky bit of this is to realize that height and r are always in the same ratio. This r to this h, this r to this h is the same ratio. So we can make that ratio 5 over 10. So we can replace r with a half h and then carry on and use the chain rule, which is always our way of doing this question.